problems are going to be very similar to the ones that you're likely to see in your class. So yeah, let's jump in and try out these word problems together. Okay, so let's start with this one. I'll read the problem to you really quick. It says, say you're on a river and you kayak downstream for 120 minutes and travel a distance of 6,000 meters. On the return journey, upstream, you cover only 4,800 meters in 120 minutes. How fast is the current in the river, and how fast would you kayak in still water? You know, how fast could you kayak if you weren't in a river, say like if you were in a lake or something? And once the answer is in meters per minute, we'll worry about that later. Okay, so key thing to notice here is that this is like what you could call a distance problem, or notice that we're dealing with, let's see, we're dealing with distances, right? So like we have here 6,000 meters, oops, and here 4,800 meters. So that's a distance, right? We're dealing with rates, which is also known as speeds, right? So it says how fast, right? And we're talking about how fast you kayak and how fast is the current of the river. And we're also dealing with times, right? We see 120 minutes here and here. Okay, so the relationship for these problems is just going to be distance equals rate times time. Intuitively, like, if you're traveling 60 miles per hour for 1 hour, 60 times 1 is 60, you should go a distance of 60 miles, right? Something like that. So all we're going to do is we're just going to plug in the values into this equation. We're going to make two equations, right? Because we have one scenario we're going upstream, one downstream, and then we're going to solve. And key thing here is, first of all, what is the problem asking for? It's asking how fast would you kayak in still water, and it's asking how fast is the current. So let's go ahead and give those, values variables from the start. So kayaking in still water, we'll call that x. So we'll say right here, x equals, we'll say the speed of the kayak. Okay, and so for the speed of the current in the river, we'll call that y. Alright, so I'll write it over here also. Okay, so speed of current is y, and that's what we're looking for, right? And notice when you're going downstream, the current's helping you, right? So your total speed is going to be x plus y, right? It's the speed of the kayak plus the speed of the river when you're going with the current. So that would be x plus y. And when you're going upstream against the current, your total speed is going to be x minus y. And you'll see that in a minute. So let's go ahead and make our equations, right? So we'll start with the downstream example. And so when we're going downstream, we traveled 6,000 meters, right? So our distance was 6,000. And then our rate, remember downstream we said it's going to be x plus y. And the time is going to be 120 minutes, right? So here we go, distance equals rate times time. Let's do that again for the other scenario. We're going upstream. So same thing, 4,800 is our distance this time. And remember, when you're going upstream, our speed is x minus y. We said that earlier. And the time here is actually the same, 120 minutes. Okay, so what can we do now? Well, let's distribute the 120 in both equations, and then we'll go on and solve the system from there, right? Okay, so let's just rewrite the first equation. Times x, and then plus 120 times y. Okay, so let's do it with the next one. So same thing except we have a minus when we distribute, right? And so notice how this problem's set up really nicely for elimination, right? These two y's are going to eliminate if we just add the equation. So let's do that. Right, we're adding them, right? I'll put a plus here. And so 6,000 plus 4,800. One way to look at this is just do 60 plus 48. I know 60 plus 40 is 100. And then we have that 8 laying over, so that's 108, right? And then we just have these two zeros. Okay, so that's 108,000. And then 120x plus 120x is going to be 240x, right? Okay, and then 1 plus 120y and minus 120y, those are the ones that eliminate, right? So those cancel. That's just plus 0, basically. Okay, now we only have an x, and all we have to do to solve now is just divide both sides by 240. And you can try it on your calculator, but I'm pretty sure it comes out to 45. Cool, so we have x equals 45, so we can go back to the top. Remember we said x is the speed of the kayak, so we just found out that that's 45. And since we're dealing with minutes and meters, that would actually be 45 meters per minute, not a standard measurement of speed, really, but for this problem it works. And so I won't write it there, but yeah, just so you know, that would be in meters per minute. Okay, now to solve for y, the speed of the current, all we have to do is plug in 45 into one of our equations and solve, right? So I'll go ahead with the first equation, so first I'll rewrite it. Let's stick with black. Okay, and then so I know it said 120 times x, which we found out is 45, right? Plus 120 times y, right? Okay, so let's do 120 times 45. I think that comes out to 5,400. Okay, and then so now we're going to subtract 5,400 on both sides, right? Okay, so that cancels there, and then 6,000 minus 5,400 is just going to be 600, right? Right, basically like, 1,000 minus 400. And so, over here we just have the 120y. And then if you divide both sides by 120, we get y equals 5. And so that means that the current was going at a speed of 5 meters per minute, and which sounds about right. Like, you could kayak much faster than the current's going, hopefully, right? So yeah, so then that would be our other answer. And that's it. That's how you solve this problem. You basically just set up a system of equations using the formula d equals r times t, and then you solve it. And then remember, when you're going downstream, or maybe you're in an airplane, you're going with the wind, that's going to be x plus y, or the two speeds added together, the speed of the plane and the speed of the wind in that example. And when you're going against the wind or against the current, that's going to be the two speeds, minus each other, the speed of the current or the wind minus the speed, subtracted from the speed of your boat or your plane or whatever. And so now that we've done that, let's go look at another one like this and see if you can do one on your own. Alright, now that we did one together, let's see if you can try one on your own. And I'll talk about it a little bit, I'll read it to you. But then see if you can try it on your own, and then afterwards, pause the video, try it. Afterwards, I'll show you the answer to see if you got it right. Okay, so this one says, an airplane flies into the wind for 2 hours and travels 860 miles. Later, the same airplane flies with the wind for 2 hours and travels 1,140 miles. What is the speed of the airplane and what is the speed of the wind? Okay, so key things to notice is it says into the wind right here, right? into the wind means going against it, and so that's where you're going to have your minus, right? Like the speed of the airplane minus the speed of the wind. And then over here it says with the wind, that's when you're going to have your speed of the airplane plus the speed of the wind, because the wind is helping you when you're going with it, right? And so like into the wind could be seen as upwind, and with the wind could be seen as downwind. And the only other things to look for, remember distance equals rate times time. I'll write that for you. Oops. Okay, and then so the distances that we're looking at here, we see 860 miles corresponds with a time of 2 hours, right? And you're going to be searching for the rate, same thing as last time. And then we have 1,140 miles goes with 2 hours again, but with, with downwind. So set it up like the last problem, give it a try, pause the video, give it a try, and then we'll check if you got it right. Okay, hopefully you gave the problem a try. And so really quick, just to show you, so you should have set it up something like this. The 860 is the, the distance for the first scenario, and that's when you're going against the wind, so that should be x minus y. Oh, assuming you made the speed of the airplane x and the speed of the wind y. You could have made it any other letters if you wanted. So you'd have 860 equals x minus y times 2, right? 2 is the time, 2 hours in each case. And then the other distance was 1140, and that's when you're going with the wind, so that's x plus y, times the time, which was also 2. So then you just solve this system of equations, and you're going to get x equals 500 and y equals 70. So hopefully you got those answers. If you didn't, probably just retry. You probably just missed a minus sign or something like that. So yeah, hopefully you got the same answers.